Hi, Art Kurtz here for Easy Access Math, and today we're going to do a factoring problem. And this problem would probably say factor completely. And when you see that, often it means you have two steps, and in this one you do. First, let's go over some factoring. Over here I have a problem where you're going to factor out the common factor. I have 2x minus 10. I see what's in common in both parts of the sign, and that's 2, leaving me with x, because I divide now 2 into both sides of that sign, x minus, bring down the sign, and 10 divided by the 2, which I pulled out, 5. So this is factored as 2 parentheses 10 minus 5. Now on this side, I have factoring out the difference of two squares. And you know this is difference of two squares when you see a perfect square on each side of a minus sign. And caution, it cannot be a plus sign. It has to be a minus sign. It's difference of two squares. Any even exponent is a perfect square, and know your perfect square numbers. They're very important, those perfect square numbers, and you'll see that, and it should stand out, and you'll say, aha, difference of two squares, and you simply take the roots of each. It's half the exponent, so half of x2 is x1 or just x, because we don't need to put that 1 in, plus the root of 25, which is 5, the perfect square of 25, and another parenthesis with x and a minus, the opposite sign, the root, which is 5. And the order of the signs don't matter as long as you have 1 plus and 1 minus. And that's the factorization of x squared minus 25. It's x plus 5, x minus 5. And you could do FOIL to do a check to see if it works. Now what you're likely to see when it says factor completely is a problem that combines both pulling out common factor and difference of two squares. You may also see problems that combine other forms of factoring. We're going to look at these two today in this lesson. First, I'm going to see common factor. That's my first step. Is there a common factor? Always look for that first. And yes, there is. 2 goes into 2 and 50. Looking at my numbers first, I pull that out, and I have an x on both sides. So I pull out an x. I pull out the lowest exponent of x, which is just the x by itself, which is x1, actually. That comes out. Then I make a parentheses, and I'm left with, because I now divide this into both sides of the sign, the 2x which I pulled out, leaving me x squared, that's a perfect square right there, even exponent. Bring down that minus sign, that comes down, and 2 into 50 is 25. Remember, that's a perfect square. The x's cancel, they're gone, x1 divided by x1, and I bring down that y squared. And that's a perfect square. Now, I just factored doing common factor, but I did not factor completely yet. And that's important. This is not factored completely, because right here, I have the difference of two squares. So I bring down the 2x, and I factor this further. It's another step. I set up my parentheses, and I split the x's, x, 1 with plus, 1 with minus. You could do that right away. And half the exponent. And now I take the root of the 25, which is 5, and half of the y on each, 5y. Half of 2 is 1, and remember, we don't put in those 1s. So I have x plus 5y, x minus 5y, and the 2x outside. Now that is factored completely. If I wanted to, I could do FOIL. And let's use a green marker for that. First, which is x squared. Outer, which is minus 5 xy. Have to be careful with those letters. Inner, which is positive 5xy. Those two will cancel out. And less, which is 5y times 5y, is 25y squared. So here's my x squared minus 25y squared, which is what I have there. If I multiply those, which I had left, the x squared minus 25y squared, by the 2x that I pulled out, and I multiply that, let's use blue, 2x times x squared is 2x to the third, and 2x times 25y squared would be 50x y squared. So as a check, by foiling and then doing distributive multiplication with the 2x, it works out to my original binomial, 2x third minus 50x y squared. It's a two-step formula, a two-step problem. You first factor out a common element, which is 2x, and then with what's inside, you further factor using the difference of two squares. You can use FOIL and distributive multiplication as a check. And that's how you do factoring completely, using common factor and difference of two squares.